Hello friends, in the previous video we discussed about the evaluation of determinants of order 2, that is how to calculate the determinant of a square matrix of order 2. In this video we are going to do the same with third order matrices, square matrices of order 3. Okay, so how to determine the determinant values of square matrices of order 3. So let us first take a square matrix of order 3. Let's say 1 1 1 2 a1 3 a2 1 a2 2 2 3 3 1 a3 2 a3 3. Okay, this is a square matrix of order 3. So if we have to determine its determinant value, it will look something like this. Okay, okay, this is the expression. So what we have done here is that when we pick or consider a particular element in a particular row, okay, here we have considered A11, then we completely omit that particular column and that particular row. So the row associated with A11, the first row and the first column, they are deleted, they are omitted. Then we consider the determinant value of the remaining elements. See here, A22, A23, A32, A33. Now we will evaluate it in the same way as we do for a second order determinant. That is, we will multiply the principal diagonal elements. For A11, we completely remove the first row and the first column, and we consider this as a second order determinant. Okay, similarly for this element A12, we will completely remove the first row and the second column. We will completely remove the first row and the second column, and we will consider the remaining elements, that is A21, A23, A31, A33, and will evaluate the second order determinant, that is multiplying the principal diagonal elements and then subtracting them. Similarly, when we consider the final element of the first row, that is A13, A13, we will completely remove the first row and the third column. It is present at the intersection of the first row and the third column, so we will completely remove that and will consider only the remaining elements of the matrix, that is A21, A22, A31, A32, A21, A22, A31, A32, and will determine the determinant as we do for a second order determinant. We will multiply the principal diagonal elements and subtract them. And finally, we can write this result as two minus A12 2, A3, 1. So simply what we have done, we have determined the determinant values by multiplying the principal diagonal elements and the other diagonal elements, and then we have subtracted them. Here also the same thing. Okay, so this is how a third order determinant is evaluated. Now this is the most conventional way of dealing with a third order determinant. Here you have to take care of the sign convention. Plus, minus, plus. Okay, plus, minus, plus. Always remember this sign convention. Don't put plus here by mistake. It will be wrong. So this will be the plus sign, then minus, then followed by plus. That will be the sign convention. When you consider a particular element of a particular row, suppose you start with first row and you pick A11 first, you completely remove that column and that row at the intersection of which the A11 element is present, and then you determine the determinant value of the remaining elements as you do for a second order determinant. You follow the same practice again, but in this time here it is minus A12, so you completely remove the first row and the second column and you determine the determinant value of the remaining 4 elements. For A13 also in the same way, you completely remove the first row and the third column and you determine the determinant value of the remaining elements and you get the result, okay, in this way. So now let us see some third order square matrices and calculate the determinant values. Okay, so now suppose we have to determine the determinant value of this uh, third order determinant. Okay, it's a square matrix of order 3 and we have to determine its determinant value. So we are considering the first row, that is the elements 2, minus 3 and minus 4. So first we consider 2, we remove the first column and the first row, so the elements are 0, minus 2, minus 5, minus 6. Okay, so this is plus sign, then here it will come minus sign, so it will be minus of minus 3. The convention, sign convention, plus, minus, plus, so it will be minus of minus 3. So we'll remove the second column and the first row and consider the remaining elements 1, minus 2, 0 and minus 6. Okay, 1, minus 2, 0 and minus 6. Next, at last is plus of minus 4. So we'll completely remove the first row and the third column and we'll consider the remaining elements 1, 0, 0 and minus 5. Now we will evaluate the final result, which will be 2 into 0 minus 10. This will be plus 3, minus of minus will be plus, into minus 6 minus 0 minus 4 into minus 5 minus 0. Okay, principal diagonal elements are multiplied, then the other diagonal elements. Here also first the principal diagonal elements are multiplied and then the other diagonal. Then here also first the principal diagonal, then the other diagonal elements are multiplied and then we subtract them. So it will be 2 into minus 10 plus 3 into minus 6 minus 4 into minus 5. Okay, so it will be minus 20 minus 18 plus 20. This two gets cancelled, so the final result is minus 18. Okay, so this is how a third order determinant is handled. Okay, So let us solve another determinant of order 3. Okay, we have this determinant which is has 3 rows and 3 columns. So we'll solve it in a similar way as we did the previous one. We're again considering the first row. Okay, 1, we'll omit the first row in the first column, so it'll be 2, 6, 1, 0. Then minus 4, we'll omit the second column in the first row, it will be 3, 6, 0, 0. Then plus 5, we'll omit the third column in the first row, it will be 3, 2, 0, 1. Okay, so it will be 1, 0, minus 6. First we multiply the principal diagonal elements, the leading diagonal, and then the elements of the other diagonal and subtract them. Minus 4 into 0 minus 0, 3 into 0 is 0, and 0 into 6 is 0, plus 5, 3 minus 0. Okay, so it will be minus 6 minus 0 plus 15. Okay, so this the final value is 9. Okay, so here we have solved another determinant of order